So yes, so I'll be talking about something that Virginia already sort of touched on, the potential role of industry standards to help to address socio-technical challenges that arise from AI with a particular focus on algorithmic bias considerations. And so I'll be looking at industry standards. So that if we think about industry standards, there's sort of two general types of standards. One is the simple how to make things interoperable with each other, the shape of a USB plug, for instance, the continuous failure of coming up with a standard for power plugs that goes across Europe. But what I'll be focusing on rather is standards related to best practices in the process of development, things like quality control and particularly ethical issues around AI, how to make sure that we address them in the best possible way. But before getting to the particular standards thing, I'll sketch out the socio-political kind of environment that these standards are being talked about. So first of all, what is really driving this discussion, the need for thinking about having best practice process standards around the quality of AI, specifically the ethical quality of AI systems. And really the driving thing has been the almost continuous flood of news stories of something having gone wrong with an AI system. It can be simple things where it's sort of a joke that something went wrong. It can be significant things such as the kind of healthcare provision that people are getting recommended, or problems in applications in the criminal justice system, for instance. So let me just run through a couple of examples of issues that have arisen with the use of AI systems, and I will usually refer to them as algorithmic systems because in the IEEE community we don't really like the term AI so much. So this is just a brief kind of summary of some of the type of examples, one of them being, so we see there, for instance, Joy Buolamwini with her the white mask that she's holding in her hand, and the reason why she's holding a white mask is because she was working at MIT with some face recognition algorithms and trying some of those out, and discovered that they just basically didn't see her face because she's a black woman. And it turns out that the AI, the face recognition algorithms, particularly at that time, that were available, they were reported to give a high percentage of correct recognition, but they'd been trained and tested with primarily white male faces. So basically, that's just an example of not having thought about the whole spectrum of potential users of the system sufficiently, and instead of having gone to the easy-to-get data sets, which was people in the labs that were developing the system and students at the places. Another example, similar, is the one next to it, which is basically the what used to be the result that you got if you typed in CEO in image search. It has been slightly updated now, and basically what you used to get was a whole load of men, almost all of them white, and the only woman CEO in the image was CEO Barbie. Now the thing is, this is not intentional. It was mining data that had been uploaded. However, because of the way in which the system is optimizing the search results, it is actually amplifying the imbalance that there was. So even at that time, if you'd actually looked at the real statistics of female CEOs in top 500 companies, it was more than 0%. It was somewhere in the 10 or 20%, I don't actually know the number, but there should have been a good number of female CEOs in those images. But the system was basically, through feedback loops, optimizing, amplifying the discrepancy that was in the input data. So all of this can basically be summarized in the bottom image there, which is, if you feed in historical data, simply easy to get kinds of data sets, which tends to be the historical data, what you would do, what you end up is building in historical biases in it, which for many cases would have been to advantage the white male person. And this is something that we as a society don't want. We are actually actively trying to get rid of those historical biases. But if we are lazy in how we use data sets in order to build our systems, in order to evaluate our systems, because it's not just for machine learning, it's also for handcrafted systems, but we are testing them, we are evaluating them with data sets as well, then we risk perpetuating old inequalities in society. And then the other one is just an example of misguided attempts of using AI to thinking that simply because it's a machine, it is objective, so we can somehow get rid of subjective judgments, even if the whole thing is subjective to begin with, because in this case they were saying, well, we want to do a beauty contest, but we want it to be objective decision of what is beautiful, and not have human subjective judgments in there, which is, I don't know, I mean, beauty contest is per definition a subjective thing. But anyway, they thought we'll just train an AI for this, but the AI came out primarily giving lighter-skinned women as so-called beautiful. Again, going back to data sets, it was mining images from actresses, etc., and so building in the kinds of societal biases that already exist. A similar kind of problem is something that came out in this paper, which was published by a group from a business school, that suggested they would use AI to try and find out whether there is something physiological about faces that indicated your sexual preference, whether your sexual orientation. And it's a fundamentally flawed study. But there's sort of a couple of things to highlight from this. One of it is it's an example of the potential problems that can arise if you make AI tools too easy to use. So people who don't understand how the machine learning system works are given an easy-to-use tool for applying machine learning. So they just apply it then to a data set. Whatever comes out must be okay. And so they just run with that. This paper was immediately criticized by the computer science community, highlighting all kinds of flaws in the assumption, the way in which the machine learning system was being used. Another aspect is to highlight that the AI system will have biases not just because of the data set that you've used, but also because of the baseline task that you've applied to it. The way in which the machine learning system was set up in this case was that it was instructed to classify people into either gay or straight. So this means it was already set up with an assumption that human sexuality is binary, and that there is no such thing as something in between. And then running with that to try to come up with some kind of an evidence for physiological markers for sexual orientation. This is an example which I've been told the next talk after lunch will go into in more detail. But the point I wanted to raise out of this one is, so this was a study looking at the use of AI systems within the criminal justice system. And there was a report from journalists highlighting that the system was unfair, that it was racially biased. But the company that had developed the system said, no, it isn't. It isn't racially biased. We've explicitly checked that it isn't. The problem is, as Virginia pointed out, what is fair depends on your definition of fairness. So in this case, the company that had developed it, they were looking at accuracy. How accurate is the system at predicting somebody's criminal likelihood of reoffending, and made sure that both black and white defendants would be judged at equal rates of accuracy, so that is to say, how frequently did it get it right? Whereas what the journalists looked at was, when it gets it wrong, what kind of a mistake does it make? And the journalists identified that in those cases where the algorithm made a mistake, it would usually make a mistake of assuming that black defendants were more likely to be strong criminals and white defendants more likely to be less criminal. So there is an imbalance in the kinds of mistakes that the system makes. And an underlying problem with this is that given the baseline probabilities within the populations, it is impossible to make a system that would be balanced both within the accuracy measurement and within the false positive, false negative kinds of measures. So what kind of fairness do we want? What do we as a society think is the more important measure of fairness in this kind of case? And my final example regarding bias issues is one that came out of the use of algorithmic system to assess the kinds of health provisions that particular people should qualify for in the U.S. medical system. So in Arkansas, they introduced a new system to rate people to identify whether they should get home care of certain type. And it was introduced primarily with the motivation of reducing costs. In order to evaluate people, every person would be assessed based on 60 different kind of questions. And those questions would be posed by the home nurse that usually would visit them, who didn't really understand why these questions were being asked. They'd just been told, go do this assessment list, hand the results over to us, and then it goes into the machine and something will spit out. The people collecting the answers to the scores didn't know why they were doing it. These scores were then filled in and fed into the system, and the result was that various people found that their health provisions were being severely reduced, especially patients who suffered from cerebral palsy. This was taken to court, and after a lengthy court investigation, they found that there were a number of issues with the system. First of all, because the people who were taking the assessment scores didn't understand why they were doing it. For instance, in the case where it asked, does this patient have problem with their feet? If the person was an amputee that didn't have feet, the assessment score might say, no, doesn't have problem with their feet, because they don't have any. But the way in which the algorithm would take that in would be to assume, this person can walk around nicely. Another problem was that it turned out there was actually an error in the code. The actual implementation of the model was wrong, and this was leading to problems for patients, but it would not have been revealed if there hadn't been a court case that had pressured discovery of how the code works. And certain medical conditions weren't actually coded in at all, including cerebral palsy. So various problems that arise from trying to use a system to optimize, underlying was the idea to optimize costs, to optimize the system, the service provision, but there's a need for good quality control around these. So the basic issue, a main basic issue is that fairness in algorithms is a messy problem in the sense that it is not just a technical thing. It depends on so many socially defined constructs, cultural differences between nations, jurisdictions, things that change over time. One of the reasons why simply using historical data can be problematic. But at the same time, as Lawrence Lessing indicated, in a sense, code is law. Once you put something into the code of the algorithmic system, the model is baked in. This now, in effect, becomes the law of how the system is going to work. It's an operationalization of the particular values at a particular point in time, which is why algorithmic systems must be transparent so that they can be checked and rechecked from time to time to see whether the system as it was built back then is still appropriate to the way in which society has changed to the current situations, and must be able to be adapted according to the new requirements. So algorithmic systems are not a purely technical thing that lives in isolation. They're socio-technical. They're built by people within organizations, within a social, political, legal, and cultural context, all of which are messy and change over time. So given these kinds of issues that have arisen, the almost weekly stories of something having gone wrong with an algorithmic system, what is the response that we've seen so far? What are the concepts of how to govern these types of systems? So the first level response, which we see at the EU level, but also national government levels, is to have inquiries about the, so we've got, in the UK, I think we're down now to the 11th or something parliamentary inquiry that is in one way or another related to algorithmic decision-making or AI, to try and identify exactly what the problem is and whether or not this should be approached. At the EU level, we also see this, something that's ongoing. That is not to say that this is not going anywhere. It is developing. They are building on each other. But at this moment, there's still a reluctance to say, we know what to do. We're going to make that decisive new change. But perhaps the high-level expert groups' recommendations will make that final step. Who knows? But if we think about what kind of governance options exist, and for instance, we can think in comparison to the way in which other digital technologies are being governed. Roughly speaking, we can think of, what is this, 5 or 6? 6 kind of ways of thinking of governing technologies. The first 2 is basically trust in the unseen hand of the capitalist market. Everything will sort itself out through demand and supply kinds of balances. Then there's potentially self-organization or self-regulation within companies themselves. Then co-regulation, so this is regulation, self-regulation, but with government oversight onto it. And then there's state intervention to say this is allowed, this is not allowed, this is how you're supposed to do things. So what is the current state of play when it comes to algorithmic decision-making systems, AI kinds of systems? So if we look at demand-side market solutions, what we've seen so far is that basically it doesn't really work. The only case in which a demand side, so that is customer side, is not happy with the kind of situation, can put pressure on the suppliers of the systems in order to change their behavior, is if the customer happens to be a big multinational. So in the case of YouTube having made an algorithmic system that wasn't paying attention to which kind of videos get which kind of advertising placed in them, the customer, in this case big advertisers, were able to push YouTube to make changes to the algorithm in order to fix this problem, because they are such huge customers. When they pulled out of putting any advertising on YouTube for a period of time, this had a significant impact on Google's bottom line, so they made an effort to change. If, however, any one of us individuals doesn't like a particular way in which a recommending system works, then there's hardly any motivation for a change. So what we've seen so far is, for instance, what we've also seen in the privacy space, the demand side push doesn't really work. Supply side, so this is to say other providers see that if they were to provide an option that is more ethical or more friendly to the end user, that this is a way in which the market can shift in that direction, because as they offer this alternative option, everybody starts to move there and picks that up. We see a couple of attempts in that direction. There's a couple of companies that are coming forward and say, we are going to offer a AI toolkit that will have tests in it for whether the data sets are balanced and those kinds of things. However, we don't really see a big pickup of these as of yet, because the network effects, those kinds of things are too strong. Market capture is too strong. If you simply offer an alternative social media platform or an alternative marketplace that is more ethical than the existing ones, the capture that is of all of the things that you've already invested in, building up your network, etc., in the existing ones, is so great that so far none of the alternatives that have been proposed have managed to pull lots of customers over. To the extent that supply-side options are being promoted, this is largely because people are seeing, the market is seeing that there might be state intervention or pushes that will cause their new product to become something that the industry will have to switch to. If we look at a company's self-organization, so this is corporate social responsibility kinds of things, what we see is companies coming out with ethical principles where it sounds nice, but you don't really know what it really means. They say they've got an ethics board, but they won't tell you who's on the ethics board, or whether they've ever made any decisions on anything. So we remain somewhat skeptical about that. But what we do see is, rather than the top-down self-organization of the company having decided we are putting in this new framework, we see a kind of bottom-up self-organization happening of people working in the company saying, I don't want to work here anymore if you're going to behave in this particular kind of way. Either they quit or they stage protests. They make sure that there's a big media fuss about it, which is going to have PR implications, such as what we've seen at Google around their Project Maven, the military drones program, but also around the Google Dragonfly for the Chinese market with censorship, and similar things at Amazon around the provision of cloud service provisions for companies that have ethically dubious backgrounds. So there's something happening there, but it's more from the bottom up as opposed to from the top down. Then we have sort of in the self-regulation space, things like the partnership on AI, companies coming together and saying we will come up with a best practices kinds of guidelines around this. And this is also sort of where then standards discussion starts to come up. And also the kind of space where some third-party certification things come in. So Orca is from Cathy O'Neill. She's set up a company that will do an assessment of your algorithmic system to look at whether or not it is producing biased kinds of outcomes and what kind of decision processes you have in there, whether you can justify that these make sense. And if it passes her test, then you can get this seal of approval. It remains to be seen whether this will be something successful. It just started, but the concept of doing some kind of certifications like this is becoming more popular. Accenture has come out with a toolkit. IBM has a toolkit around how to test your data sets to see whether they're biased, to check whether your algorithm is behaving in a biased way. And then if we go to co-regulation, we have things like Privacy Shield and Safe Harbor kind of agreements in the privacy space, and one could think of something similar to that, which is to say governments imposing a certain kind of, these are things that you need to be able to show that your system does in order to get certification under this, which will then allow you to do certain kinds of markets. So for instance, we can think of certain requirements that you'd need to reach in order to be allowed to offer your system for in the public procurement kind of space, those kinds of things. And then there's the state intervention, which is, for instance, what's being looked at in New York City with the AI transparency bill that was passed, requiring algorithmic impact assessments for if the system is going to be used by the city. The exact nature of how the algorithmic impact assessments are going to be done is still to be defined, but this is something where basically the state has said this is an important thing. There is a lot of vulnerable populations that could be affected by this. So in order for you to be able to offer yours up to as a possible solution, you need to comply with certain requirements. And France, with the digital bill, the bill for the Digital Republic, has also introduced various specific requirements around public sector uses of algorithms, requiring transparency, for instance. Now, as I mentioned, industry standards came in here at the sort of the company self-regulation kind of branch self-regulation space, and it also plays sort of in the space of co-regulation, self-regulation. So we had the discussion about ethical principles being proposed, both within some companies, but also professional organizations such as the Association of Computing Machines, which are a nice first step. They indicate at the high level certain kinds of things that you should be thinking about when you're building a system. But generally what they lack is a specificity as to how you're supposed to do this. How can I say, based on this list of ethical principles, when I then look at your product, is it compliant or not? What exactly is the process that I should be going through in order to check this kind of compliance? And so FATML, the Fairness, Accountability, Transparency Machine Learning Group, have also got principles of accountability. And this is the Google's AI principles, ethical principles, which also, again, very high level. Sorry, I'm going a bit quick to get to the next point. But as I mentioned, a problem with ethical principles is that they can feel very unenforceable. You don't really know how can I hold you to account for whether you are compliant with your own principles. So the IEEE has decided a couple of years ago, in 2016, to launch a global initiative on ethics of autonomous and intelligent systems to try and go beyond the simple principle statement. One part of that is the ethically aligned design document, which discusses the issues in more detail. But what I'm going to talk about more is the standards projects that are connected to this. So this is the first real push to try and look at standards that are for AI, autonomous intelligent systems, that are focusing not on interoperability between systems, but rather focusing on the ethical questions. How did you make sure that your system is transparent so that it can be explained to end users? How did you make sure that data privacy is taken into account when building the system? How did you make sure that the system isn't biased? How are you governing the use of particular vulnerable kinds of population groups, such as children and students, etc.? And so the group that I'm chairing is the algorithmic bias considerations, which is why I'll go into that in more detail. There are other standards activities happening at the moment regarding AI, such as ISO IEC. They are currently working on a new group of standards to do with artificial intelligence. This is the ISO IEC JTC1SC42, if you want the whole code. However, a marked difference between the ISO initiative and the IEEE initiative is that ISO is still looking at it more from a technical kind of perspective. So for instance, the ISO work regarding trustworthiness is primarily focusing on reliability and robustness in the sense of, does the system produce predictable kinds of results when the context that it's being applied to has certain kinds of variations in it. They're not so much focusing on the questions of how are particular user groups being affected by it, or those kinds of ethical questions. So there is a distinction that IEEE is really focusing on the ethics questions, whereas ISO is more looking at the technical questions around standardization. So how are we approaching, for instance, in the algorithmic bias considerations working group, how are we approaching the question of developing a standard on an ethical process of AI development that will look at the question of bias? So the baseline starting point is that what we're trying to minimize is unintended, unjustified, or unacceptable kinds of bias. We need to specify this because depending on how you look at it, any system that actually works will have some kind of bias in it. If the search engine works, then I hope that the result I get is biased to fit the search term that I put into it, and not just some kind of random response. But what we don't want is that the response has a bias in it that doesn't make sense within the context of the use, and that isn't acceptable within the legal context where it's being used, or isn't acceptable by the population that's going to be affected by it. So can you provide a justification for the decision-making process and the outcomes that you're getting? So what are some kind of causes of algorithmic bias? Well, typically, the causes go back to insufficient understanding of the context of use. So this was, for instance, the example with a lot of face recognition kinds of systems, not sufficiently understanding the diversity of the population that's actually going to have to be processed by the system. Failure to rigorously map the decision criteria. So going in and just feeding it a certain kind of data set, it seems to be working with this kind of data set. I haven't a clue what the machine learning system actually learned as the criteria. Then trying to apply it, and afterwards somebody might do the detailed test of it and find out that the way in which this algorithm is actually distinguishing things, it's distinguishing your wolves from your husky dogs, is based on the presence of snow in the background and has nothing to do with the thing that it was supposed to actually make the decisions on. So understand what are the decision criteria that are actually being used by the system, and failure to have an explicit justification for those criteria, which is to say you haven't really thought this thing through, you don't know whether or not these kinds of criteria are actually okay to use in this particular context. And in order to address those, you need to think about who will be affected, what are the decision optimization criteria that actually went into this, how are they justified, and are these justifications acceptable where the system is used. And this is, for instance, something that comes out also in the algorithmic impact assessment proposals that have been put into in New York by AI Now, where one of the important aspects within the algorithmic impact assessment is to involve the community where the system will be used within the evaluation of whether this is an acceptable system. And so based on these concepts of what needs to be considered, the current draft of the standard has the following kinds of sections in it. It has some foundational sections, so this is thinking about the background of the system that you're using, identifying a taxonomy of different types of algorithmic bias, legal frameworks within which these systems might be used, what are psychological causes of bias that might come in, and this is to a large extent to do with the developers of the system, but also somewhat to do with the end users. How are they likely to interpret the results that are being provided to them? Typically, confusions around correlation and causation, but also cultural aspects. Within this particular culture, certain things are acceptable, which are not in another one. And then there are the more technical kind of aspects, which is sort of more the typical type of content of a standard, to do with the design stages of your system. What are the possible stages within the design where bias might get introduced, where you need to do certain kinds of checks? How did you categorize people into groups, etc.? And so based on these kinds of general sections, what we're looking at is, at a high level, is this kind of a process where you have initially, when you go into the design, a understanding of the context in which you're working, and then based on which you can make a general risk assessment of this kind of a system that we're developing poses these particular kinds of potentials for generating bias, which we need to think about when we're evaluating. And then depending on whether you were applying this standard in the case of redeploying of a system or building a new one, we might go towards directly to the green or towards the yellow. And so then on the one hand, we've got evaluation of how the system is working and checking that to look for biases, which is some of the things that, for instance, the Accenture toolkit could be used for. And on the other hand, it's looking at the build process within that. How did we make sure that our training data sets are good? How did we evaluate the algorithmic processing, those kinds of things? And underlying all of this at the output is the need for having clear documentation to provide transparency to users and potentially to regulators around how the system has been, how during the development of the system, controls were put in place to make sure that unintended bias is being avoided. And so my final slide is just to highlight on the certification aspect, so that IEEE has recently also started some work together with the government of Finland and other regulators, as well as industry. It's inviting industry to participate in this in order to develop a third-party certification procedure, which will then be something that other third parties can provide for the industry. So we're thinking something similar to CE certification, but then looking at ethics of autonomous systems. And that's it. Thank you very much.